Hey Algebra people. Today we're going to be taking a look at powers of exponents and how do we simplify exponents here in algebra. Let's start looking at this case where we have 2 squared multiplied by 2 cubed. Looking at just 2 squared, I can rewrite that as 2 times 2 because when you have the base to the second power, you're going to multiply the base by itself 2 times. Now similarly, that 2 to the third power, we're going to just multiply 2 by itself 3 times. And when you put all of this together, you notice that you have actually 2 to the 5th power because we have 1, 2, 3, 4, 5 2's written down here. So this whole adding the powers, we can test this hypothesis by taking a look at one of these other problems. Let's take a look at the third one. We've got 5 cubed and 5 to the 5th power. Now if I add those exponents, I got 3 plus 5, and that's equal to 8. Let's just move that aside for now, and we'll see. Let's check the other way that we do things. So 5 cubed times 5 to the 5th power. And this has 1, 2, 3, 4, 5, 6, 7. Yes, that has 8 5's. So that's the same thing as 5 to the 8th. So it seems as though then I can have a rule where if I do x squared multiplied by x to the 6th power, that should just be equal to x to the 8th power. 4 to the 1st power multiplied by 4 to the 5th power, that should just be equal to 4 to the 4th power. Remember, for this to work, you have to have the same base on all of the exponents. So for example, this would not work with 3 to the 4th power multiplied by 4 squared. That's definitely not equal to, well, I don't even know what the base would be. So, how would we even do this? Still not sure what that's going to be equal to. Okay, we now have one rule for exponents, and our next rule here would be taking a look at how does division work. So here we're going to take all of everything in the numerator, and we'll break that down into 4 to the 3rd power. So we got 4 3's on the numerator. The denominator is 4 squared, so we got 2 4's in the denominator. And then we notice that 2 of the 4's in the numerator can cancel out with 2 of the 4's in the denominator. So this is just equal to 4 over 1. And I'm going to make a special thing here to say that this is actually 4 to the 1st power. Going back to the original problem, I see 4 cubed and 4 squared. How do I get 4 to the 1st power based on 3 and 2? Well, that's kind of a subtraction. 3 minus 2 is 1. So maybe what the rule here is, this is going to be equal to 4 to the 3 minus 2 over 1. Let's try it over here. We'll do this 2 ways. We'll start with on the second problem. We'll start by looking at, well, the numerator is definitely more powerful than the denominator. So I'll make this 2 to the 5 minus 2 power over 1. So this is 5 minus 2 is cubed. So this is 2 to the 3rd power over the 1, or just 2 to the 3rd power. We're going to move that over to the side, and then we're going to do this the old-fashioned way. 2 to the 5th power is 5 2's on the numerator. 2 squared is 2 2's in the denominator. And then we start canceling out some 2's. So this 2 over in the numerator cancels out with that 2 in the denominator. This 2 in the numerator cancels with this 2 in the denominator. And look at that, I get 2 to the 3rd power over 1, or just 2 to the 3rd power.
So this subtraction seems to be the ticket here. So we'll look at number 3 here. We've got x to the 6th power over x cubed. We can express this as x to the 6 minus 3 power, which is just x to the 3rd power. This fourth one's kind of curious because we have 3 to the 4th power over 3 to the 4th power, which using my rule would just be 3 to the 4th power minus 4, which is 3 to the 0 power, or just 1. All of this leads me to that general rule is if you have fractions, then you're going to subtract the power. Here on letter C, we're going to have a power of a power. So let's take a look at this a long way with number 1. This is 2 squared to the 4th power. Since the power is for the parenthesis, we're going to rewrite the parenthesis 4 times. And then just fill them in with whatever is inside the parenthesis. In this case, 2 squared. Using the first rule that we came up with, since we see all the bases are 2's, we can just add these powers together. So this is 2, 4, 6, 8. So my answer should be 2 to the 8th power. And now we're going to look for our pattern. How could we have gotten that 8 using only the 2 and the 4 that we saw here? And this time it looks like we would multiply our powers. So 4 times 2 is 8. So we're going to take a look at number 2 now. And we see 7 to the 3rd to the 2nd power. So since we have a power of a power, we should be multiplying the powers here. So this should be 7 to the 6th power. Let's check and see if that worked. Let's move the result over to the side. We have a parenthesis squared. So we're going to multiply the parenthesis 2 times. Inside the parenthesis we have 7 cubed. And then using the rule that we just found out for multiplying exponents, since these two have a 7 as the base, then this is just going to be 7 to the 3 plus 3, which is 7 to the 6th power. Notice how it checks out with my rule. So this seems to be the rule then. If we see the power of a power, we're going to multiply. Let's take a look here. We have y to the 3rd power to the 3rd power again. 3 times 3 is 9. So this result should be y to the 9th power. Our next one is x to the 4th power squared. And 4 times 2 is 8. So this should be x to the 8th power. Okay, we have 2 more of these to do. And this is going to be the power of a product. So product, remember, means a multiplication. So what if we have 2 times 5 to the 2nd power? Well, I have something squared, so I'm going to write a parenthesis twice. 1, 2. Inside each parenthesis is 2 times 5. Using the commutative property, I've got 2 2's, so that's 2 squared. And I also have 2 5's, so that's 5 squared. So it seems like if we have the power of a product, we're kind of distributing the power to each of the factors. So let's test this out on number 2. We've got 5 times 4 to the 3rd power. If we're correct, then we should get 5 to the 3rd power times 4 to the 3rd power. Doing this the old-fashioned way, I've got a 3rd power. So that means 1, 2, 3 parentheses, and inside each parenthesis should be 5 times 4. Counting up exponents, I've got 3 5's, so that's 5 to the 3rd power.
And I also have 3 4s. And that's 4 to the third power. So this looks like this rule of distributing into a product is going to work. So here for number 3, it may not look like a product because there's no multiplication dot, but this is 6 times a, the whole thing to the second power. And I can distribute this power into the product, so we have 6 to the second power multiplied by a to the second power. And we'll do the same thing here with number 4. We've got a product to the second power. So this is going to be 3 to the second power multiplied by x to the second power. So the rule here seems to be if we have a power of a power, we're going to distribute the power to each factor. Now the last one we're going to look here is going to be the power of a quotient. Looking at number 1, we have 2/3 to the second power. So since it is the power of a parenthesis, we're going to write the parenthesis 1 2 times. And then we just fill in that parenthesis. My numerator here is 2, and I've got 2 of them. So 2 times 2 is 2 squared. And then on my denominator, I have 3 times 3, which is just 3 squared. So the rule here seems to be if we have the power of a quotient, we just need to distribute the power to the numerator and the denominator. Let's take a look at number 2. We've got 4/3 to the third power. So we'll just rewrite our quotient, and we'll give that third power to both the numerator and the denominator. For number 3, we've got x over 2 to the third power. So we rewrite x over 3, and we give that third power to both the numerator and the denominator. Last one we have here, we have a over b to the fourth power. So rewrite a over b and give that fourth power to the numerator and the denominator. The core concepts that we learned here, the first one is anything to the 0 power is 1. So for example, 4 to the 0 power is equal to 1. Just be careful here though, because 0 to the 0 power is undefined. So that is not something which we can do here in algebra, not 0 to the 0 power. For a negative exponent is basically the reciprocal of a positive exponent. So here, if I have 4 to the negative 2 power, that's the same thing as 1 over 4 squared. One shortcut way to think about this is when you see a negative power, it's on the wrong side of the fraction bar. So here in notes I have 3 squared multiplied by a to the negative 2 power multiplied or all over b cubed. This a to the negative 2 power is on the wrong side of the fraction bar because it has a negative exponent. So we're going to take it and we're going to put all the positive exponents in the places where they currently are. 3 squared has a positive exponent, so we're going to keep it in the numerator. B cubed has a positive exponent, so we'll leave it on the denominator. But a squared, we're going to put it on the denominator because it had a negative exponent in the numerator. So to give it a positive exponent, we have to put it in the denominator. Next, we have those 4 powers, or those 4 properties we just went over. If we have if we multiply 2 powers with, or 2 exponents with the same base, we just add the exponent, or the power. If we divide, we're going to have, if we have the same base, we're just going to subtract the exponents. So 4 to the 6th over 4/3 is 4 to the 6th minus 3. If we have the power of a power, like 4 to the 6th to the 3rd power, we're going to multiply the powers. So we've got 4 to the 6th times 3, which is 4 to the 18th power.
The power of a product, we're going to distribute the power to each of the factors. And then the power of a quotient, we're going to take the power and distribute it to both the numerator and the denominator. And with all of these properties, hopefully that will get you on your way to looking at more exponents. So we're going to take a look at some example problems in the next video.